Today we bring you the second video in the History of Supernova Discovery series. If you have not watched the first video in the History of Supernova Discoveries video series, we invite you to watch that video before watching this video. That video is in the playlist 16 History of Supernova Discoveries. Also, in the description of this video, there is a link to the previous video. We invite you to stay until the last moment of this video. The Renaissance period witnessed a significant advancement in supernova observation with Tycho Brahe's meticulous documentation of a new star that appeared in the constellation Cassiopeia on November 11, 1572. Though other European observers claimed to have noticed it earlier, possibly as early as August of that year, it was Tycho's precise measurements that definitively established this object was not a nearby atmospheric phenomenon, but existed at the distance of the fixed stars. This observation directly challenged the prevailing Aristotelian cosmology, which held that the celestial realm beyond the moon was unchanging and perfect. Tycho's nova, as it came to be known, remained visible to the naked eye until March 1574, reaching a brightness comparable to the planet Venus, with an apparent magnitude of approximately -4. The supernova's exceptional brilliance allowed it to be visible even during daylight hours at its peak, underlining the extraordinary energy released during this stellar catastrophe. Unlike some other historical supernovae, Tycho's nova left behind only traces of glowing nebulosity rather than a distinct nebular remnant visible to optical telescopes. However, the explosion site remains detectable today as a radio and X-ray source, providing valuable data for modern astronomers. A significant breakthrough occurred in 2008 when an international astronomical team analyzed light from the original explosion that had been reflected off nearby interstellar dust. This light echo technique conclusively identified Tycho's nova as a Type Ia supernova. This classification indicates it resulted from a thermonuclear explosion triggered when a white dwarf star accreted material from a companion star until reaching critical mass. Beyond its scientific significance, Tycho's nova played a pivotal role in dismantling the Aristotelian conception of immutable heavens, helping prepare the intellectual foundation for the scientific revolution that would transform humanity's understanding of the cosmos. Just over 3 decades after Tycho's observation, another brilliant new star appeared in the night sky in October 1604. This supernova, occurring in the constellation Ophiuchus, was extensively documented by the German astronomer Johannes Kepler, though he was not the first to observe it. Kepler's detailed account, published in his 1606 treatise, De Stella Nova in Pedi Serpentarii, on the new star in the foot of the serpent handler, provided such comprehensive documentation that the event bears his name despite his not being its discoverer. At its maximum brightness, Kepler's supernova, SN 1604, outshone Jupiter, reaching a magnitude between -2.25 and -2.5, making it visible even during daylight hours. Over subsequent months, the supernova gradually diminished in brightness, equaling Antares by January 1605, fading to 5th magnitude by October that year, and finally disappearing from naked eye visibility by spring 1606. Modern astronomical analysis has classified SN 1604 as a Type Ia supernova, the same category as Tycho's nova. In this type of stellar explosion, a white dwarf in a binary system accumulates material from its companion star until reaching the Chandrasekhar limit, approximately 1.4 solar masses, at which point its core ignites in a runaway thermonuclear reaction. This classification is supported by the absence of any identified surviving central star at the explosion site, while the visible light remnant appears only as filaments of surrounding nebulosity. Kepler's supernova remnant emits strongly in both X-ray and radio wavelengths, providing valuable data for contemporary researchers. The precise distance to Kepler's supernova remains somewhat uncertain, with estimates ranging from 10,000 to 23,000 light-years, though recent studies suggest a distance of approximately 16,300 light-years, 5 plus or minus 1 kiloparsecs. Historically significant as the last supernova observed in the Milky Way visible to the naked eye, Kepler's supernova represents a critical data point in our understanding of stellar evolution and galactic history. A watershed moment in supernova astronomy occurred on August 17, 1885, when French astronomer Ludovic Gully inadvertently observed a new stellar object during a public stargazing event. Initially dismissed as scattered moonlight, this observation went unreported. 2 days later, Irish amateur astronomer Isaac Ward independently spotted the same object, but similarly did not immediately publish his finding. It was Estonian astronomer Ernst Hartwig's observation on August 20, 1885, subsequently communicated via telegram on August 31, that brought widespread attention to this celestial phenomenon. This object, designated as Andromedae or SN 1885A, would prove historically significant as the first supernova ever observed outside our Milky Way galaxy. Appearing in the Andromeda galaxy M31, SN 1885A reached a peak apparent magnitude of +6, making it just visible to the naked eye under ideal viewing conditions. At the time of its discovery, astronomers did not yet understand that Andromeda was a separate galaxy outside the Milky Way, a fact that would not be established until Edwin Hubble's groundbreaking observations in the 1920s. Consequently, while S Andromedae represents the first extragalactic supernova observation in astronomical history, its true significance was not appreciated at the time. This supernova provided critical data that would later help establish the true nature and distance of the Andromeda galaxy. To date, SN 1885 remains the only supernova observed in Andromeda by astronomers, despite decades of subsequent monitoring. Its peculiar classification as a Type 1 supernova with unusual spectral features continues to interest researchers studying supernova diversity. The discovery of S Andromedae marks a pivotal transition point between historical naked-eye astronomy and the modern era of telescope-aided extragalactic research, foreshadowing the explosion of supernova discoveries that would occur in the 20th century. This video is getting long, so I'll stop here. Expect the rest of this in the next video. You can watch more videos like this by clicking on the cards that appear here. If you want to see our next video as soon as it comes out, subscribe to our YouTube channel and click the bell icon. Thank you very much for watching the video so far.